Hello everyone, this is me Explore Gamer. Today I'm making a game where the health doesn't just decide if you survive, it also decides how good the game looks. At full health, everything looks modern and high quality, but the more damage you take, the more the graphics fall apart. The resolution drops, the visuals get worse, and the game slowly devolves into something from the older generation, straight out of a PlayStation 1. And honestly, I have no idea how this project is gonna turn out, whether it's gonna be amazing or absolutely terrible, so let's try it together. For the game itself, I'm gonna make a third-person zombie survival shooter. You play as a guy stuck in a city with nothing but an AK-47 and surrounded by zombies everywhere. Every time a zombie attacks you, your health decreases. Once we build the core gameplay, we're gonna add the main twist of the game. That is the graphics system. So I created an empty project in Unity, then I made the simple plane and capsule setup to test everything out. After that, I quickly created the scripts needed for the third-person shooting system with the help of ChatGPT. Nothing too fancy, just the basic stuff to get things working. I made the camera slightly to the right of the player so that we can clearly see what's ahead without blocking the view. And as you can see, the raycast is working properly. Great, so now let's create the player model. Now to create the 3D models quickly, I'm gonna be using Meshy. Meshy is an amazing platform that can generate 3D models from text or images. Now for this video, I'm gonna create a 3D model of our main character. I want him to be a handsome looking guy wearing a suit. So I'm just gonna search for a reference image to help the AI. Alright, I'll use this one. I want the model to have a low poly style for now. Since I told we're gonna be switching the graphics, so I want a high poly model and a low poly model. Let's create the low poly model first. Alright, let's wait till Meshy creates the asset. There we have it. Now let's create the high poly version. So I'm gonna select the standard option. Let's wait and see the results. Damn, look at my bro with the drip. You also have the option to create videos using the text to video feature. So let's create a title design for our game. I described how I want it to look, and now let's see the results. Then I created a zombie model using this reference image, and it recreated it almost exactly how it looked. And I mean exactly like the image. I'll tell you why. There is this rigging feature too in Meshy where you can automatically rig your model and apply animations to it. It even comes with a bunch of different animations built into the platform. So while I was testing them out, I noticed something weird. The original reference image actually had a watermark on it. So as expected, my 3D model also got that watermark. But Meshy also had an option to edit the texture. So I selected the watermark area and told the AI to remove this watermark, and boom, it actually fixed it perfectly. There's also a batch feature where you can create multiple 3D models in one go. I dragged in a bunch of building images and told it to quickly generate all of them, and as you can see, it generated 3D model replica of them. You can generate images and 3D models from a text prompt, and you later use that image to create a 3D asset from that. Meshy can do all of it. So I recommend you guys to check out Meshy if you're looking for an easy way to generate 3D assets for your game. Link is in the description. So I'm gonna be using this city model. I'm pretty sure a lot of you guys already recognize this map because I've used it before, but honestly I just love this model, so that's why I keep using it again. This game is gonna take place in this small junction of the area. Zombies will keep spawning in, and our job is to survive by shooting them. Now let's drag in our player model. That's done. Now let's set up his animations. I'm gonna be using this 2D Cartesian blend tree for this. Basically it changes the animation depending on the direction we're moving, just like in the classic third-person shooters. Let me add the gun and position it properly in his hands. Now as you can see, it works perfectly. Let's just add some muzzle flash and sound effects and make the shooting a lot better. Now let's add the zombie that we created using Meshy. I'm gonna use Unity's nav mesh system to make the zombie AI chase the player. Nav mesh is basically Unity's built-in pathfinding system for the NPC, so I quickly set everything up, and now let's see if the zombie actually follows us.
These niggas out here snitching, they with the rat pack.
Why is bro aura farming? So I added the animation, and now as you can see, the zombie walks exactly like how a zombie should. You can also shoot it and kill it. Then I added a feature where the zombie can attack us, and now we are dead. Except we can still shoot and move around.
What the hell?
Okay, I gotta turn this off. Let me fix the code. Great, so now we're actually dead and we can't move because this is how dead people are. They are not supposed to move. Then I set up zombie spawn points where the zombies will keep spawning infinitely, while also making sure the number of zombies does not go above the limit. I created a health bar so we can actually see our health getting depleted. Now our game is basically working like a normal zombie shooter, so let's add a feature that's actually gonna make it different from others: the graphics degrading system. I imported our city model into Blender to remove the unwanted buildings because we only need that junction area for the game, and I also separated certain objects that we're going to replace later when the graphics decreases. It would wouldn't be practical if those objects were still connected to the rest of the city. I created a script called Graphics Manager. This script is basically gonna control the graphics of the game. First, let's start with something simple we can implement quickly, reducing the texture resolution. I used a script from ChatGPT that works using MIP maps, which lets me lower the resolution of the textures during the gameplay. And surprisingly, it actually worked. Whenever the player's health decreases, you can see the entire game texture becomes blurry, but I don't want this blurry effect. If you remember the old PlayStation 1 graphics, the textures look pixelated and sharp instead of blurry. That's the kind of look I wanted. Right now, Unity is basically applying a blur filter to smooth everything out, but I want that authentic retro feel. So I selected all the textures and changed the filter mode from bilinear to point no filter. And now as you can see, all the textures look pixelated and low quality, right, in a really crispy way, exactly how I want them to look. Then I also decreased the render distance as the health went down and turned off the shadows when the health is too low. Now next up, I'm gonna start removing these environmental props as the player health decreases. First of all, you can see these small paper bits lying around everywhere. That's way too much detail for an old game. So once the health goes below 80, these paper props are gonna disappear, and when the health drops even further, things like these trash cans are gonna start disappearing too. Basically, I'm assigning different priorities to every props in this scene. The least important ones disappear first, while more important ones stay longer. Now I'm gonna add both high poly and low poly versions of the zombie. When the health goes below 50, the zombie model switches to low poly version, and if the health goes above 50, it changes back to the high poly model. As you can see here, the model swapped instantly once the health drops below 50. And I did the same thing for the player as well. As you can see, here's the high poly model and here's the low poly model. They both look almost identical, except one has way less details. And I'm pretty sure you guys can tell which one is the low detail version. Yeah, it's the left one. Okay, just kidding. Now when the health goes below 50, you can see the player changes into the low poly version. In older games, you might have noticed that some objects were actually just 2D images placed in a way to make them appear like 3D objects. This technique is called billboarding, and it was mainly used to save performance by avoiding the need to actually render a 3D object. So we're gonna use that same thing with this steel railing over here. First, I'm gonna take a screenshot of this railing and turn it into a texture image. Then I'll create a quad, which is basically just a flat 2D object in a 3D world. I'll apply this texture on top of it, and now as you can see, it looks identical to the railing as long as you don't view it from the side. This is basically how they did it back in those days, and I repeated the same for the other railings. Now before we move on to the final step, which is lowering the actual game resolution, I want to add one more thing, the classic wobbly effect of the old PlayStation games. Back in the PS1 era, the 3D models had this weird shaky and unstable look to them. This happened mainly because of the hardware limitations of the time. From what I understood, it was basically some complicated math issue where instead of using a floating point, they used fixed point calculations and you can check the detailed descriptions. You can find way more detailed explanations on YouTube if you want to know more about it. But here we are going to bring back that effect. I want that authentic PS1 look when the health is too low. Now of course we can't change the math calculations in Unity, so we're going to fake this effect using a shader effect. Thanks to the ongoing nostalgia trend of people trying to bring back the PlayStation 1 effect, there's a lot of tutorial on how to get that PS1 look in Unity. I followed this tutorial by Ryan Street and made this shader effect. Now let's try this shader effect on our player material and see how it looks. Yo, this guy looks like a Minecraft character now. Okay, I definitely don't want this intense. Let's decrease the cell size a bit. Alright, I think it looks much better now. Once we lower the resolution too, it's probably gonna look more natural. Then I applied the shaders to all the buildings and the environmental textures around the map, and yeah, I realized that the characters and environment actually need different cell sizes for the effect to look good, so I made separate versions for both shaders. I duplicated the shader and used the different cell sizes for the characters and the environment. Finally, I found the right wobble amount for the environment, and now as you can see, it looks pretty good. I mean pretty bad. All that's left is for the final touch of decreasing the resolution. Now reducing the game resolution dynamically in a seamless way is impossible. So instead we're going to fake that effect using something called the render texture. Basically, if we attach a render texture to the camera, then whatever the camera captures will be rendered onto that texture instead of directly coming onto the screen. Then we can use this texture on a UI image which is stretched across the screen. And a cool thing about the render texture is that you can change their resolution to however you want. So what we are actually seeing while playing the game would be the render texture and not directly to the camera. I found the correct resolution sizes for 1080p, 720p, 480p and 240p in 16:9 aspect ratio, and then created a separate render texture for each of them. Now as you can see, the quality quality of the game keeps decreasing as we take more and more damage from the zombies. Let's add one more final touch, the aspect ratio. Older games used to be 4:3 aspect ratio, while modern games are 16:9 for the wider screens, which is the standard format now. So when players' health gets really low and reaches the 480p stage, the aspect ratio is gonna change to 4:3 as well. I'm gonna fake this effect by adding this black bars UI elements on the sides of the screen. Then I'll move the health bar inward so that it doesn't go outside the area. Now it genuinely looks like a real game from late 90s or the early 2000s. At this point, I want to add more health pickups so the player can recover health while surviving it. But instead of normal health packs, I'm gonna make him pick up graphics cards.
What?
Yes, the streets are gonna be filled with floating graphics cards, and picking them up will increase your health while also increasing the graphics quality of the game again. So that's it for this video. I hope you guys enjoyed it. We now have a game which changes its graphics depending on your health, just like we planned. Thanks for watching, and I'll see you guys in the next video.